Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now we are starting with lecture number 3, and this is about coordinate geometry. And let's learn some new concepts. So let's get started. Let's talk about the concept of parallelogram. What is a parallelogram? What is the definition? The definition is opposite sides are parallel as well as equal in length. So let's draw a parallelogram and let's see how it works out. So on this page, let me draw a parallelogram. Let me draw two lines like this. And let me paste it over here somewhere. Let me draw another line like this. Okay, let me copy it. Let me paste it over here. Okay, so this is a diagram that I have just drawn in front of you. So over here, these two lines are parallel as well as equal in length. These two lines are parallel as well as equal in length. Let me label this thing as A, B, C, and D. Let me write down the coordinates of A as 1, 0. This is 5, 0. And this is 2 right, 4 up. So that would be 7 and 4. And this would be 2 right, so 3 and 4. So let me just use an eraser. Okay, now, first of all, I want to prove that this is a parallelogram. So let me take coordinates of A, which is 1, 0. Let me take coordinates of D, which is 3, 4. Let me take coordinates of B, which is 5, 0. Let me take coordinates of C, which is 7, 4. Let me calculate gradient of AB, the blue line. So the blue line is over here. So gradient of AD, that is 0 minus 4, 1 minus 3. 0 minus 4 is negative 4. 1 minus 3 is negative 2. That comes out to be plus 2. Similarly, for BC, gradient of BC, that is 0 minus 4. And this is 5 minus 7. That is negative 4, negative 2, which is plus 2. Hence, I have proven that yes, AD is parallel to BC. That is the first thing. The next thing, the length also. Let's calculate the magnitude of AD. So magnitude of AD, that would be going like this. 0 minus 4 whole square, 1 minus 3 whole square. 0 minus 4 whole square, 1 minus 3 whole square, square root. So this is 16, this is 4, that is square root of 20 units. Similarly, magnitude of BC, let me draw this line straight. Magnitude of BC, that is 0 minus 4, 5 minus 7. BC, that is 0 minus 4, 5 minus 7 whole square, that is 16, that is 4, that is square root of 20 units. So therefore, I have proven that AD is equal to BC. Now, let me add a page. That means not only these two lines are parallel, they are also equal in length. So let me grab this thing and paste it on the next page. Let's do some more working because we are doing some inquiry-based learning and then working it out. So now over here, if I talk about D and C, the y coordinate is the same, that this line is parallel to x-axis. So line DC is parallel to x-axis. The y coordinate remains unchanged. And therefore, the equation of the line DC, that is y is equals to 4. The same goes for AB. The y coordinate is unchanged. These 2 points lies on the x-axis. So again, line AB is also parallel to x-axis. Gradient is 0. And y coordinate unchanged. Both lines AB is parallel to CD. Gradient is 0. And this equation is y is equals to 0. That is the x-axis. So we have proved that AB is parallel to DC. What about the length? As far as the length is concerned, this is 3, this is 7. So DC has a magnitude of 4 units. Similarly, this is 1, this is 5. Therefore, AB also has a magnitude of 4 units. So not only DC is equal in length to AB, DC is also parallel to AB. Therefore, this shape over here, it's a parallelogram. Now, let me send this image to you so you can double check on the group that is about on 2026 AS Maths. So let me just highlight it over there. Where is the group going? Okay. So how to prove the quadrilateral is a parallelogram. Is it all good? All clear? Just acknowledge the message on the group. I hope everyone is on that particular group. People are slow in replying. People be a little bit fast. That's the only way in which I communicate. That is on the WhatsApp, not on Zoom. Chalaji. So that's how you prove it's a parallelogram. Now, let me take this figure again and let me do one more thing. These two are parallel. These two are parallel. Let me do one thing. Let me take A and C. So A is 1, 0. C is 7, 4. B is 5, 0. D is 3, 4. 5, 0 and 3, 4. So this is B, this is D. Let's calculate midpoint of AC. Let's calculate midpoint of BD. So midpoint of AC, MAC, should be like this. MBD, BD should be like this. So let me take the x coordinates. So that's the x coordinate, x coordinate. Let me write it down and take the average. Let me take the y coordinate, write it down and take the average. So this is 1 plus 7 divided by 2. This is 0 plus 4 divided by 2. 8 over 2 is 4. 4 over 2 is 2. That is the midpoint of AC. That's the first thing. Let me highlight it. That's the blue one and that's the red one. Now let me take the x coordinate, take the average. Let me take the y coordinate, and take the average, and let me write it over here. So now over here, this is 5 plus 3 divided by 2. This is 0 plus 4 divided by 2. This comes out to be how much? This comes out to be the same thing. That is 4, comma 2. That is the midpoint of BD. So now you have unlocked a new property. So that new property of a parallelogram is midpoint of diagonals is the same. In a parallelogram, midpoint of diagonals is the same. Is this thing all good, all clear? So that's a very, very important property that is useful. Now, my question to you is, just ignore this, the line equation that is of no need right now. This is a past paper question, but I'm using it for my own interest to prove something. So let me just remove this thing. And my question to you is simple. Prove that A, B, C, D is a parallelogram. That's 14 over here. A, B, C, D is a parallelogram. Also, check whether all lengths, all sides are of equal length or not. Whether all sides are of equal length or not. And this proving that it's a parallelogram, use midpoint property. So let me pause the recording. You can have a good look, and then you can get started. So now, people, I need to check whether it's a parallelogram or not. So midpoint property is the best. Let me take A. Let me write A over here, which is 1, 3. Let me write C over here, which is 12, 14. It's not necessary that they always give a diagram, but the main thing is the first and third. The first and third, that is a diagonal. Similarly, the second and fourth, the second and fourth, that's another diagonal. So now let me write over here, this is B, which is 4, 12, which is D, 9, 5. And based upon this, we will work it out. So now over here, the midpoint of AC, the midpoint of AC is 1 plus 12 over 2. And this is 3 plus 14 over 2. Leave the answer in the fraction form. That is 13 over 2, 17 over 2. Midpoint of AC. And midpoint of BD should be 4 plus 9 divided by 2, 12 plus 5 divided by 2. Therefore, midpoint of BD is 13 over 2, 17 over 2. Yes, these two things are the same. The x coordinates are the same. Naturally, the y coordinates are also the same. So yes, E is the midpoint. So E is the midpoint of these two diagonals. Therefore, it's a parallelogram. So therefore, it's a parallelogram. I have proven this. That's the first thing. Now, how can I use it? I can use it if I have two vertices of three of them, and I can find the fourth one. I'll do that in a short while. So now this thing is done. Check whether all sides are of equal length or not. So let me check the length of adjacent sides. Let me choose A and B, 1, 3, and 4, 12. So A is 1, 3, B is 4, 12, B is 4, 12, and let me pick C, 12, 14. C is 12, 14. Yes, it's a parallelogram, but what kind of parallelogram? So now the magnitude of AB, that is 1 minus 4 whole square. This is 3 minus 12 whole square, square root. Negative 3 square is 9, and this is 9 square, which is 81 square root. That is square root of 90 units. Therefore, let's calculate BC, which is 4 minus 12 whole square. This is 12 minus 14 whole square, square root. This is 8 square, which is 64. This is 2 square, which is 4. This is root of 68. Since adjacent sides are unequal, are not equal, therefore, it's just a parallelogram and not a rhombus. Of course, it's not a square. It's not a rectangle. So therefore, it's a simple parallelogram and not a square. So now let me write over here this thing, just a parallelogram and not a rhombus. Is this all good, all clear? Just put a tick mark. Just keep your group open at the very top. And I hope my voice is all good, all clear. Yes, it's all good. Now let's make it into an exam type question. So let me grab this figure and let me first copy it from here. No, it won't take the whole thing. And let me make an exam type question over here. So A is 1,3, D is 9,5, A is 1,3, D is 9,5. Hold for a second. C is 12,14. And B is unknown. So now the question would be like this. Let me remove this thing, the extra stuff. That's over here. Let me grab a white marker. So that is not needed at the moment. Let me remove it. Okay. Now this is what the question will say. It would say exam type question. I would always label it ETQ. Okay, that is my numbering, my branding. Exam type question. Given that A, B, C, D is a parallelogram, find the coordinates of A, D, C, B. Find the coordinates of B. Now focus on A, focus on C, focus on A, focus on C, 1,3 and 12,14. A is 1,3, D is 12,14. Focus on B, focus on D. So B is XY, unknown. D is 9,5. And let's get working. So now the midpoint of AD, that should equal midpoint of BD. I think this one is C. So let me just erase it. This one is C. So midpoint, and also over here, I need to erase it. Midpoint of AC is the same thing as midpoint of BD. Now let me get a highlighter. And this is 1, this is 12, this is X, this is 9. Let's focus on this. Let's just focus on the X coordinate first. So if I focus on the X coordinate, and then I'll focus on the Y coordinate. So first of all, that's the X coordinate, that is the Y coordinate, this is Y, this is Y, this is Y, this is Y. The average of X coordinates should equal average of Y coordinates. So I'll write 1 plus 12 divided by 2 should equal X plus 9 divided by 2. Is this thing all good, all clear? I took the X coordinate, took the average. I took the Y coordinate, took the average. I'll also do it one other way. Over here, this is 3 plus 14 divided by 2. This is Y plus 5 divided by 2. So now 2 will cancel out. 13 is X plus 9. So therefore, X comes out to be 4. Again, 2 will cancel out. 17 is Y plus 5. Y comes out to be 12. Therefore, the coordinates of B is 4, 12. This is one way of working it out. Now, what I'll do is that let me grab this thing and let me copy it, or not cut, my bad, add a page, and some people would prefer it this way. What I'll do is that let me first write down the coordinates completely. So midpoint of AC is 1 plus 12 divided by 2, 3 plus 14 divided by 2. Midpoint of BD is x plus 9 divided by 2, y plus 5 divided by 2. Now make them equal. The y coordinate should equal y coordinate, the x coordinate should equal x coordinate. So for the x coordinates, for the y coordinates, for the x coordinate, this is 1 plus 12 divided by 2. This is x plus 9 divided by 2. And this is 3 plus 14 divided by 2. And this is y plus 5 divided by 2. 13 is x plus 9. X comes out to be 4. 17 is y plus 5. And then y comes out to be 12. Therefore, the coordinate of B is 4, comma 12. All good, all clear? So now let me send it over to you. I want you to at least copy down this particular question so that you are very, very sure exactly what you are doing. So now, people, we are done with this. Let's move ahead. And now let's look at another figure. And let me label A, which is negative 80 and 1612. So this is negative 80. This thing is 1612. This thing is B, which is 2, comma 10. This is D, which is 6, comma 2. This is M, the midpoint of BD. Now, first of all, I will ask you, and I'll do it actually. Let's make it exam type question 2. Prove that A, B, C, D is a rhombus. So if I want to prove that it's a rhombus, what needs to be done? There are three things that could be done. What I can do is that let me take A, let me take B, let me take B, let me take C. So A is negative 80, B is 2, comma 10. Again, write it over here, 2, comma 10, and this is 16, comma 12. So I'm working on adjacent sides. Of course, opposite sides are already parallel. That also I'll prove. So now AB magnitude, that is equals to negative 8, negative 2 whole square. And this is 0 minus 10 whole square under root. That is 100. This is 100 square root, which is root of 200 units. Similarly, if I talk about magnitude of BC, that is equals to 2 minus 16 whole square, 10 minus 12 whole square, square root. 14 square is 196, 2 square is 4 square root. That is square root of 200 units. Now, first thing first, that is, I have proven adjacent sides are equal in length. So that is the first thing that I have done. That is, the adjacent sides, they are equal in length. Now, the second thing, now prove that diagonals have a common midpoint. So negative 80 and 1612. So this is negative 80 and 1612. This is A, this is C. And then B, and then D. What is B? B is 210 and 62. 210 and 62. Let me calculate the midpoint of AC. So this midpoint of AC, that should be negative 8 plus 16 divided by 2, 0 plus 12 divided by 2. Similarly, let's calculate midpoint of BD. So therefore, midpoint of BD should be 2 plus 6 divided by 2. And this is 10 plus 12 divided by 2. This is 10 plus 12 divided by 2. This is 8 over 2, which is 4. This is 12 over 2, which is 6. This is midpoint of AC. Midpoint of BD is equals to 8, comma 8 over 2 is 4, comma 6. So the second thing is also proven. So I have also proven, okay, yes, it's a parallelogram and all sides are equal. So therefore, a parallelogram with equal all sides equal, could either be a square, could either be a rhombus, and we can see it for sure. We can also calculate the gradient. So now let's calculate the gradient of adjacent sides, which is this thing. So let me calculate this thing, adjacent sides. And since the angle is not 90 degrees, still prove it. Don't go on the looks. So now our gradient of AB is 0 minus 10 minus 8 minus 2. That is negative 10 over negative 10, which is positive 1. Gradient of BC, that is 10 minus 12. And this is 2 minus 16. 10 minus 12 is negative 2. 2 minus 16 is negative 14. That comes out to be 1 over 7. Gradient of AB into gradient of BC does not equal to negative 1. In other words, AB is not perpendicular to BC. This is not. Therefore, ABCD is not a square. ABCD is actually a rhombus. Is this all got all clear? So now this one, let me just write it over there. So now not a square, but a rhombus. Is this all got all clear? Just acknowledge this thing over here. Yes, waiting for it. Not a square, but a rhombus. Is this all got all clear? Yes, why? Acha. I think I wrote on the wrong group, my bad. So now it's over here. Yes, not a square, but a rhombus. Now you can acknowledge. So all my online classes, the acknowledgement will be on this particular group. Correct? Now let's do one other thing. That is, let's take this diagram and let's look at a special property. And over here, so now there is a special property, and let me just write over here. Let's work on a special property of square and a rhombus. What is that special property? We will soon have a look. Let me draw two diagonals. So one diagonal is this, the green one. That is one diagonal. Let me draw another diagonal. That is this reddish kind of one. And let me calculate the gradient of this. Let me calculate the gradient of this. So over here, this is A, negative 8, 0, and this is C. I think this is 16, 12. This over here is B, 2, comma 10. It's not drawn to scale, neither it has to. And D is 6, comma 2. Gradient of AC, that is 12 minus 0 over 16 minus minus 8. 12 minus 0 is 12, 16 plus 8 is 24. That comes out to be positive half. Similarly, gradient of BD, That is 10 minus 2 over 2 minus 6. 10 minus 2 is 8. 2 minus 6 is negative 4. That comes out to be negative 2. Now focus over here. Gradient of AC, this one is gradient of AC is positive half. Gradient of BD is negative 2. They are negative reciprocals of one another. Since gradient of AC into gradient of BT multiplied to give you negative 1, that means AC is perpendicular to BD. This is that special property. What is the special property? The special property, what it says is this. That is in a, let me add a page. It says this: in a rhombus or a square, the diagonals are perpendicular to one another. So now the special property is also done. Special property of rhombus, square, diagonals perpendicular. Okay, so this is all got all clear. Now let's try out a past paper question based upon this knowledge. The same diagram, but now we take it as a question. And that is this question number 3 from the old topical book, which is available on my website. The new topical book will only be available as a printed form. Okay, so no, I don't need to do that. Now, let me send this image also to you to have a look. Now, what I want you is to try out the question for 6 minutes, and then I'll give you the solution. 5 minutes, 6 minutes, try it out. Shalaji, so let's go to this particular question. Now, this is an examination question. I have used this diagram earlier to prove my point that this is a parallelogram. Now, this is a CAIE 9709 paper 1 exam type question. Actually, this is an examination question. Now it says the diagram shows a rhombus. The diagram shows the rhombus ABCD. It says it's a rhombus. The point B and D have coordinates such and such. That's B, that's D. A lies on x-axis. A lies on x-axis. Midpoint of BD is M. Midpoint of BD is M. Find by calculation, not by drawing, by calculation. What the coordinates of each of M, A, and C. 6 marks, 6 minutes maximum. Let's get started. Now, first of all, let me write over here B. Let me write over here D. This is 210. This is 62. This is 210. This is 62. Therefore, midpoint of BD is M. So the coordinates of M is 2 plus 6 divided by 2, 10 plus 2 divided by 2, 8 over 2 is 4, 12 over 2 is 6. That is the first thing that's got. We achieved. Now it says A lies on x-axis. Now let me draw this line over here. This is BD. This one is AC like this. It's actually AMC. Let me calculate gradient of BD. So gradient of BD is this thing. Let's go this way. 10 minus 2, 2 minus 6. 10 minus 2, 2 minus 6. That is 8, negative 4. That comes out to be negative 2. Now let me add a page. Therefore, gradient of perpendicular AMC should be positive half. Why? Because in a rhombus, diagonals are perpendicular. So make a habit of writing this thing so that the examiner is happy with you and it's eager to give you the marks. Now we have the coordinates of M, which is 4, 6. Let's find equation of AMC. So therefore, y minus y1 is equals to half x minus xy. That is the equation of AMC. Line meets x-axis at A. So therefore, y coordinate is 0. So negative 6, 0 minus 6 is half x minus 4. Negative 12 is x minus 4. Negative 12 plus 4 is equals to x. X comes out to be negative 8. Coordinate of A is negative 8 comma 0. Have a look at the diagram. So I calculated the midpoint. I calculated the gradient of the green line. The gradient of the pinkish line is the negative reciprocal, that is positive half. The line passes through M, line passes through C, line passes through A. I found the equation of this line. When the line meets the x-axis, y coordinate is 0. I found the coordinates of A. So far, so good. So the coordinate of A is found. So hold for a second. Where is this thing? So far, so good. This is up till you found M and you found A. Now, what is left? The last thing that is left is C. Now it's a parallelogram. So the midpoint M, the midpoint of A and C is also M. So we have A, which is negative 8, 0. So let me add a page. So now we have A, which is negative 8, 0. We have C, the coordinates are X and Y. We have M, the midpoint is 4, comma 6. So now let me focus on this. Take the X coordinate, take the X coordinate, the average is 4. So minus 8 plus X divided by 2 is 4. And this is minus 8 plus x is equals to 8. Therefore, x comes out to be, this is minus 8, 0. And the coordinate of C is what we are looking for. And the coordinate of M is 4, comma 6. So minus 8 plus x divided by 2 is this thing. Therefore, x equals to 16. That is one thing. Let's focus on the y, and then this. So now this is 0 plus y divided by 2 is 6. Therefore, 0 plus y is equals to 12. Y equals to 12. So this is 12. This is 16. Therefore, the coordinate of C is 16, comma 12. The coordinate of 16 is 16, comma 12. All good, all clear. So let's stop today's session over here. So lecture number 3 of coordinate geometry focus was on parallelograms and all these things. That is all done and dusted. So almost we are done with every single concept except for one small concept that will be coming up in the next class with a lot of past paper questions. Take care, everyone.